Volume sound good? Or is that loud? Yeah, good, because I don't know how to change the volume of these. All right, welcome to the last presentation of this conference for you guys. We're going to be talking about assessing the future robot and equipment risk assessment requirements and methodologies. I'm going to go over what requirements there are for robot systems. The risk assessment side is kind of where I'm focusing. Of you people here, who has a robot system at their facility or plant? Most. Is it packaging more than? Some, yeah.
Also have about a 90,000 square foot automated storage retriever.
Oh, okay. Yeah, those in packaging is kind of where I've been seeing a lot of the break-in into the facilities, and from there it just kind of grows. Are they all industrial, or do you have collaborative robots as well? Anyone? Industrial. All industrial, okay. So we'll go over a few. My name is Adam Harose. I'm with Conversion Technology, CTI. We're a EHS consulting firm outside of Atlanta. From the robot perspective, I'm an associate member on the Robotics Industries Association, specifically for the R1506 rulemaking committee, which is the standard for industrial robots. And I'm also on the team for the OSHA Alliance, kind of working, I'll get more into that, but working with OSHA to kind of train them a little bit more on what industries are doing, how they do it, what they need, give them a little bit more knowledge from the industrial side of things. I spend about half my time in the office and half my time on site, so I do get to see a good range of equipment, industries, different sectors, kind of how the robots are being used, and I'll show you a few examples from me. Like I said, Conversion Technology, we're EHS consulting. Most of us are engineers in Atlanta. Our main departments are environmental compliance with both local, state, federal regulations, safety and OSHA compliance, as well as the robot risk assessment side. And then we also do a lot of specialties with combustible dust, hazard assessments, testing, equipment design, stuff like that. And then also part of the process safety management side, RMP, RAGAGAP, ammonia, stuff like that. So kind of what we're going to be talking about, I'm going to go over a few definitions, just so that way we all understand what I mean, kind of when I say some of the words, because a lot of things can mean a few different pieces of equipment. And then I'll kind of show you just a brief intro of how robots have been changing over the past several decades. I'll explain what the different standards and regulations are, kind of from the mandatory side as well as the not mandatory side. And I'll give you a little hint of some of the standards kind of in the pipeline that we're talking about in our rulemaking committees, as well as I just got an email for our agenda next week when we meet to go over some of the standards. And then I'll go over kind of what is a risk assessment, how to do it, some of my methodologies for it, what to look for. I'll give you as many tips and tricks as I can when I'm on site, and then I'll show you some examples and kind of hopefully do it a little bit together to kind of waken up for the day. And then I'll show you some good safeguard methods that you can use. Some are better than others. Some can be designed to be personal for your site. And then I'll kind of give you a little summary. So some of the words I'll be saying, when I say robot, what that typically means is basically the articulating arm, or if it's a storage, automated storage, we're talking about the specific kind of articulating piece that's moving your containers, or that's actually moving your packaging. So we're talking about the actual articulating arm. Typically it's going to be jointed. Attached to that is your end effector, which is your hand, basically. So you'll see an example of a collaborative robot that has a 6-jointed articulating arm with a suction end effector, because it just picks up packages, puts them on a table to then get finalized. Excuse me. The robot system, that's everything that's included. We're talking about the robot arm, the tool, the end effector, conveyors going in, your safeguards, your program, your controller, your power unit, potentially the operator. I kind of like to include those as well. So we're talking about the robot system is the entire system. I mentioned end effector. The user, that's going to be pretty much you guys. That's the people, as OSHA will call the employer, the people using the robot that have your requirements for these risk assessments. The integrator, those are the people or companies that you've hired to install and program your robot. Typically, they will also provide some risk assessment tools, and they do have requirements for it, which I'll go over. And then you'll hear me say teach mode, or T1, or teach, or manual. That's the manual operation of the robot. That basically means that operator has picked up the pendant, turned the key, it's now in manual mode, and that operator is controlling the robot arm. So there are requirements for that as well, and I'll go over. And that has its own, safety risks that I'll point out, because when you put something in the control of a person, I'll let you know how people can be quite hazardous themselves. So robots have been around for the better part of a century. We're getting close to it from when they first started. But for the past several decades, they kind of started not being able to be used in industry too much. But then with innovations in the automotive field, they have really kind of broadened that space of their uses. As I'm sure you can see, if you Google kind of industrial robot, you're going to get a lot of automotive plants. And they have kind of bridged that gap of the robot-human interaction as well. So that's where a lot of the innovations are coming from. There's a lot of representation from automotive in the rulemaking committees as well, which is why I think when consultants like me come in that don't do too much work with automotive, they're like, okay, good, kind of another perspective. Currently, from that gap, we have a lot of different types, uses, and styles of robots. We have like AGVs, or automated guided vehicles. That's a arm mounted on one. Does anyone have automated forklifts at their facility? So that's kind of the big push right now that I'm seeing, which they have their own issues to deal with. Even timber, which is usually a little bit later to get into the swing of technology. Timber's getting used for a lot of dangerous, repetitive type jobs. And then there are multiple types of robots. I'm typically talking about the articulating robot on the end, or on the top, excuse me. That's a 5 or 6 axis robot. It has joints. It can move. Typically, the bigger the size, the longer the reach, which is, I've done some facilities that really have they don't need a lot, but they need to be able to reach far, so they have to get a bigger robot. And we'll talk about how you can get around with that. And then you have things like a SCARE robot, which is the Selective Compliance Assembly robot, which I see a lot in the tooling side. Usually those are like the sidekick for the heavy industrial robot. They kind of adjust the tools and calibrate, and then the robot itself will pick up the tools. And then you have the Cartesian robot, which is kind of like a 3D printer. It has for the most part, fixed Z-axis and operates in the XY. So it's going to, again, that's more I see on the tooling, calibration, and lab side, that you really only need specified little movements. So the future of robots is not exactly what we've seen in the movies. They are not currently becoming self-aware, so I think we're okay. But the future that I'm kind of noticing is that bridge into other sectors. Agricultural help, you can get a drone to kind of help fumigate or spray your farm, or just, again, repetitive, tough jobs for a person to do. But again, as robots get into the field, they still require humans to kind of make the decisions, decide what's what, and then obviously oversee maintenance and stuff like that. And then a big kind of, I'm just waiting for that roller coaster to move fast, is the service robots. A few months ago, we had our rulemaking committee meeting in Boston. The day before, they spent the whole day talking about service robots and kind of what's next in the pipeline for that. And then obviously the robot-human interactions. So when I say collaborative robot, I'll get more into that later, but the collaborative robot is basically a robot designed to be around people. That does not mean that they are just safe out of the box. Nothing is ever safe out of the box. But there's more implementation that allows people to interact with them and have more intrinsically safe items kind of inherently designed into the system. But this is really kind of my past few risk assessments have been on the collaborative side, especially in packaging. It's just packaging tends to be where all these robots are getting started. So a typical robot cell, when I'm talking about a robot system, is we have the articulating arm in the middle. It doesn't have to be in the middle. It can be in the corner. It can be wherever you want, really. With the end effector and tool, or the part that it has to pick up. The safeguarding or perimeter fencing, which for heavy industrial robots, perimeter fencing tends to be that first safeguard. I'll go over plenty of other options. But it works great. We have the conveyors going in, because typically a robot needs things to do. E-stops and hard stops, which are required in your robot cell. And I'll talk more about it, but the E-stops, keep in mind of where you're putting them. One E-stop doesn't mean, hey, we have an E-stop, we're good to go. You kind of want them in as many places as possible that any operator, it's readily accessible to that operator. And then other safeguards like light curtains, awareness, and signage, and do not enter signs and stuff like that. The bare basics, by definition of a robot system, is you have your robot arm, the hand, or the end effector, your power supply, and your controller. With that, you have a robot system. Obviously, to scale is different, but this is pretty much what you buy, and everything else is what you add on, or what the integrator wants to put in. So the standards and regulations are put out by a few people. OSHA itself does not have a regulation covering robots. They have guidance. They have their OSHA technical manual, does have a whole section on robot safety. OSHA has e-tools on robots, but they have not come up with a regulation. OSHA, they don't move that fast when coming up with regulations. So what they do is they rely on other kind of consensus standards, which is the ANSI standard and RIA, Robotics Industries Association. We've paired together to come up with these consensus standards. Our consensus standards for the United States are based on the international and European standards. So ISO 10218 parts 1 and 2 are the basic overarching European standard for robots. We've adopted those and have literally just converted that into ANSI R 1506 2012. So the thing with that is, as ISO updates their standards, therefore we update our standards in the U.S. So I think ISO is working on their next update in a couple years, so kind of be on the lookout for that. From the OSHA perspective, I've spent many years on running our OSHA compliance department, kind of sitting on usually the opposite end of the table as OSHA. So I've worked with them, I've talked with them. The one way that they're really going to come, because OSHA is the enforcement arm of all these standards, is they have to somehow figure out what's a citable, what's a notification, or a violation, and what are you violating. So if there's an accident based on your robot, let's say it hits a person or they trip or whatever, they're going to look for what can they do. So the main citation that I see from OSHA is the 1910-212 for general industry, which is machine guarding, because in that regulation, this is A3II, it says the guarding devices shall be in conformity with any appropriate standards. Basically, OSHA has now covered it all up and saying, well, it's not our job to tell you which standards. It's your job to figure out which standards you comply with, and then you need to comply with them. So there's a lot of, for those of you that have been in safety long enough, I think you know the generic gray areas of 1910 especially. But that is their way of saying if they show up on site, they're going to say, hey, where's your risk assessment? According to R 1506, you're supposed to be doing this. So have to comply with all standards. So. OSHA's phrasing, as they've presented to us in the RIA association and stuff, as robots are machines and as such must be safeguarded in ways similar to those presented by any hazardous remotely controlled machine. It's basically saying it's a piece of equipment, you got to guard it. What do you guard against? A lot of things. You can put a lot of guarding, but if somebody can get around it, you kind of got to take that into consensus. Also, they can always do the general duty clause, 5A1 of the OSHA Act, basically saying workplace should be free of hazards. So good luck explaining that to certain people. And then, of course, from the maintenance, calibration, manual operation mode of that robot system, this is the lockout tagout, 1910-147, which can be tough to lock out a robot system. And you'll hear me, some of the things I've heard of, hey, you're going in to do some maintenance, non-routine, tasks. Why didn't you lock out the system? Oh, well, it takes way too long to start up. Or you lock out that whole system, you turn it back on, you now have to reteach that robot. You now have to hand guide it to make sure it knows where it's going. It takes too long. Well, for those of you that have ever had to deal with a lockout tagout accident, it's let it take too long. It takes about 10 minutes, 20 minutes. So, and then I don't know how to reboot the program. Maybe you have an integrator that did not teach your people how to program that robot system, which happens. So no one knows how to do it. They just know how to run the program. Well, that's great for that integrator that's going to charge you hourly to troubleshoot with you, but you need to be able to do these things on site. You got to work with your people. The last couple of facilities I've worked with, their people go to about a 2-week training at the robot, not at their facility. They'll typically go to either a class or like Yaskawa or Fanuc will put on a training session for them where they'll get to learn how to program the robot, teach the robot, something like that. And then, of course, the ANZ RIA R1506 standard, which is the overarching standard governing robot systems. In there, they go over methods of safeguarding, and I'll show you some other standards that explain it. And then they also have the risk assessment requirements in there for both you as the user, for the integrator, the OEM or manufacturer has their own set of requirements. And then if you ever look at the ISO standard, 10218 or something like that, there's parts 1 and 2. It's kind of split between integrator and end user. So you can kind of... here's the list of different standards. There's plenty to choose from, depending on the type of system you're looking at. R1506 covers your system, general. If you're implementing collaborative robots, I'm not going to go over too much with the European standards, but the technical report, which is TR, technical report, R15606. And then we are working on a 706, which is basically how to decide if you want a collaborative robot. I had many comments on it because it wasn't the most intuitive from an end user perspective. And then different things like what your end effector requirements are. They're working on it, on how to fit it, size it, length, because you have to take that into account with your system design. User guidance, safeguarding. Kind of each individual component has a technical report that goes with it. And these technical reports and consensus standards, for the most part, are informative. They're not mandatory requirements. However, if you don't follow your consensus standards and OSHA shows up, why didn't you follow these best practices brought to you by the entire industry of robot users? Oh, well, they're not required. I was like, well, you saw in the 1910-212 that they have to follow all corresponding standards. So you they're not required, but they should be done. Let's just, leave it at that. And then just to briefly say, because I do have it in my first slide, a lot of these can be implemented for other machines and equipment. My background is on the machine guard design side of things, which is how I got into the robots, because somebody needed a design of guarding for that, and turns out you can't just, hey, I'm a mechanical engineer, I can figure this out. There's a lot more to it. So machine safety, I would also look at the ANSI B11.0 and B11.19 standards. That's going to help you also with the risk assessment. So understanding risk, I think we all know for the most part what's a hazard, what's risk. So that hazard is really that dangerous situation, and that risk is the likelihood of exposure to that. So you really want to take a step back and figure out, well, who owns safety? Who owns the safety at your facility? The equipment manufacturer definitely has their own responsibilities. We all know that. Sometimes I think they forget it. One of the issues I've had dealing with OEMs and equipment manufacturers is they can easily tell you, well, that's OSHA certified, meets all OSHA requirements. I'm going to tell you right now, OSHA does not certify anything. I've gone through OSHA authorization for 10 and 30-hour trainings and worked with OSHA. Yeah, they don't certify any. They're not going to take that liability on. So when you buy something and it says, in the McMaster car, it says, oh, it's OSHA certified. Well, it's not, but they can say that. So it's one of those you want to know that ahead of time, because then you can say, well, let's look at it, and then I'll tell you more of their requirements. And then of course the employer or user, they have the OSHA standpoint of, well, they need to make that workplace safe. And then the big thing I hear the most, well, it came that way, right? So it's fine. Well, I've spoken at other conferences specifically about the phrase, but it came that way for machine guarding. Because it might have come that way, but that doesn't mean that it's perfect. Things will be designed to have their own inherently safe systems, but then you need to say, well, I'm going to put it in this part of the process and add this conveyor and put it in this location. And I have a lot of curious employees, so I need to guard it in this way. You need to kind of make it fit for your facility. The employee, that's the day-to-day operator. They're there to make sure they go home every day. But then what I typically hear from them is like, oh, I just do what I'm told. I was like, well, that's great if you're told the right thing every time. But we know that between when there's a deadline or interpretation, that can kind of get skewed a little bit. And then OSHA's, they're the ones that they're not going to show up unless something happens. As a VPP facility, obviously you can work with them a little bit more one-on-one without the whole citation part of things, which is good. That a lot of facilities don't get that resource. And OSHA still, we're still trying to build that knowledge for them to be able to assist. So I mentioned risk and hazard. We'll kind of look at both. You need to take both into account for a risk assessment. And then kind of what is a risk assessment? By definition, the ANSI B11 standard, the process by which the intended use of the machine and tasks and hazards and the level of risk are determined. And that is, in a nutshell, that's a risk assessment. You are looking at tasks, the hazards, you're calculating how much risk is associated with that. And then in R1506 is where the requirement for a risk assessment is. It does specify that your integrator or OEM, depending on how you bought your robot, is required to provide you a risk assessment. Theirs is typically preliminary because they're going to say, I don't know where you're putting it in your facility. I'm selling you a robot arm. I'm not installing your safeguards. So there's a lot of people that have to get involved, which is why just buying it from the box it's usually not enough. And then this is from the standard, kind of an infographic of how to do a risk assessment. I don't find those helpful for me, but some people. So. When I talk about risk assessment, that was the general side of it. Typically with me, I like a comprehensive risk assessment. That is kind of what OSHA, ANSI, consultants, engineers, that's what we are looking for, a more comprehensive approach. You want to look at every individual task, any hazard that's present or that could be present. In my mind, there is no impossible situation that you should not bring up during a risk assessment. Well, what if that falls after this falls, after somebody trips here, and while there's a power outage? The likelihood of that is negligible, but it's possible. Again, you've been in safety long enough, you know that it only takes about 8 things in a row to go wrong, and then someone loses an arm, which happens. So those are the things that you want to do. It's comprehensive. Being proactive versus reactive, I'm sure you hear that plenty, especially as VPP facilities. Aside from it being, in my mind, a little bit cheaper and easier to be proactive because you have a longer amount of time to do it, You can figure out your capital expenditure, your priorities by doing it ahead of time instead of waiting for something to go wrong. Because then you have to shut down until something's fixed. Or OSHA is going to show up and now you're going to have to deal with fixing and abating those issues, plus dealing with an injury, plus you can't operate, plus it's really expensive because you only have 3 months to do it. So take that proactive approach, including a diverse team. Who here's EHS and who here's maintenance? No? Okay. So EHS, typically we're the ones saying, hey, we need to do a risk assessment. Oh, great. Here's safety. Wanted to do a JSA on everything. Yeah, pretty much, actually. But taking that diverse team, because you guys are going to be aware of the standards and the potentials and kind of how things look on paper. But you want that maintenance supervisor or you want that team lead and operator especially to be part of your risk assessment team because we know what things look like on paper. We know how they're supposed to work. But the operator is the one that says, yeah, that's great, but this is what I have to do 6 times a day to clear jams. Or, yeah, that's fine, but when this product comes down the line, we have to change it up really quickly. So you need those different viewpoints of it for sure, because you can't just take this on as one person. You want that team, you want that accountability, and then also keeping those operators. My tip for that is get those old timer operators that people listen to. They may be the ones saying, "Well, I don't need this. I've never gotten hurt. I've been here 35 years." That's true until he gets hurt, but then he takes that ownership of safety, and then. You don't want that guy that's been here 35 years to see the new kid not doing something right. He's gonna say, hey, excuse me, I put a lot of work into this. You listen to what I'm doing, and then that young kid's gonna be safe for the rest of his time there. So it's kind of, you really want that diverse team. And it's not just something to check off an audit list. You really want to go through it. So with risk assessments, there's a few different approaches, qualitative and quantitative. You can pick, it's up to you. I'm an engineer. I love numbers. They make me happy. So I usually will provide a quantitative risk assessment. And basically what that does is to me, it's easier to prioritize, well, where does the capital, time, and energy need to get put? Because instead of just a low risk, I can give you a few things that have a low risk, but one may be a 18, one may be a 36. Which one's more important? I'll show you what I mean by that. So the qualitative side, this is out of the standard. This is a risk assessment, kind of a tree. You look at this. You look at each individual task, and then each individual hazard for each individual task, and say, what's the severity? What's this? What's that? Okay, I have a high risk. Okay, we got to take care of that. The conversion technology approach, similar to this, but we come up with, instead of a high risk, we give you a number. So you may be in the orange or the red, but it kind of will help separate your priorities a little bit, just where you need to spend that capital, kind of what's high, what's higher. Yeah. So I talked about your A team. One thing to talk about is I just can't emphasize enough. I tend to repeat myself in presentations, but using those operators, I would recommend getting supervisors and stuff from around the facility. Get a lot more people involved because you may be just over that robot system, but there's a lot of affected employees around it that are good to be aware of, and then incorporating that into training down the road. So the first step, kind of your preliminary step before you start your resources, you have your team assembled. You want to sit with them and say, what's our scope and what are our goals? Is your scope to look at one robot system with the hope of putting in 10 more in the line? Or are you looking at one robot system to ship to 25 of your facilities and mass produce so everyone can kind of use it? And then is your scope just to say, well, we want this system with a goal of nothing above a high hazard? Well, that's great. That'd be nice. But occasionally you might get an unacceptable hazard. Or do you want everything to be in the low risk range? So you want to set those goals because it's only going to help you go through that risk assessment process as a team. So there's a lot less infighting, which will happen, but it's a little bit less when you have your goals set. So the first step of a risk assessment is identifying every single potential task of that robot system. The robot arm itself is going to have several tasks, but don't forget that an operator may have to come into that unit to load corrugate or slip sheets for those packaging lines. Maintenance, their own set of tasks. Is that end effector, does that robot arm automatically change it, or is it a manual thing that they have to do when they change products? At what point does the robot have to be recalibrated? Don't forget calibration as a task. And then, of course, anything that would put that robot into T1 or teach mode. Because typically, I'll probably say this again, but when in teach mode, a lot of the sensors and scanners shut off. Because someone needs to be kind of walking with that robot, typically, in teach mode. So you kind of want to keep that. I recommend watching that operator do teach. Actually, I prefer to do a risk estimate while everything's operating, because that's where you can see those little gaps. You know, is a person in teach mode walking right next to that robot, behind the robot? Are people able to come in and out of the cell, which I've seen? And there's a lot of blind turns sometimes. So you want to come up with those, talking about normal operation, changing those end effectors, housekeeping, and all maintenance. And you know, if you have area scanners, someone's going to have to clean those scanners periodically. Use that as a task. The next step is, now that you have every single task listed, in each task, what are the potential hazards? Normal operation has a few hazards, but typically the cell is designed to be operating without people around it. But is there potentials for a slip, trip, fall if somebody has to load, unload parts? You know, that robot's operating, it's going to keep moving, but somebody has to put in a new empty tray so it can load those pieces. Some of us talked about earlier, loading molten cores into a hammer press. What's the potential risk for that? What do you think one risk that they didn't notice till we brought it up in a risk assessment would be? Yeah. Getting struck by, so you can see that I'm right up against that perimeter fence. That's one thing I always look at on paper, typically before I can go, is, great, you designed that perimeter fence. Well, how much of a reach does your robot arm have with an end effector and the part it's holding? And this is a molten core. So how hot is that? It's molten. So how close can that get to my finger in the guard fence? Or what happens if it drops that molten core and that core starts rolling? Can it get underneath? Those are the little things that you may not think about. Operators like, why would you put your finger through the fence? People do. That's why there's a dummy stick that you can stick in to say, well, how far do I need it? I see head shaking, like, yeah, we've all been in safety long enough. So, some other common hazards that I like to look at. Slip, trip, fall is always a big one. That is one of the number one or number two workplace injury causes. And when people are coming in and out of a cell, there's a lot of wires, a lot of power cables, Ethernet cables, whatever it is, air lines going through these cells. You kind of want to think about that, especially in the design of it, which we'll get into. Being struck by the robot is the biggest. That usually has the highest severity. From an industrial robot, these things are massive. They can move heavy and quick. So getting struck by one of those has a very high severity. Versus a collaborative robot, it's still severe, but it's less severe because it's not going to hit you as hard. They're lighter robots. They're designed. They're going to hit you, but they'll stop. And I'll get more into collaborative later, but pinch points and amputations, there's joints on a robot arm, so you want to be careful of that, or getting pinned in the cell. You want to look, is there a way that an operator, for whatever they're doing, gets stuck between the robot and the perimeter fence? Because that's a big deal. That is a big deal. There are a lot of requirements on kind of where a person can stand. And typically, if a person's right next to a robot, that robot shouldn't really be operating. The falling end effector or tool, the example I just recently did a risk assessment on a collaborative robot where they in-house designed the male-female connections for for the end effector, and then they twist the couple, and it locks in place. Well, I asked them, well, how do you know if it's locked in place? Well, it's an 8-pound assembly. It's not very difficult to do. I was like, I understand that, but it was suction actuated, so it picks up pieces and lets go. So there's air running through that end effector. So if it's not coupled properly, that air turns on and shoots that end effector right down. Is it gonna kill you? No, but it'll hurt. It might give you a laceration. And you don't want someone to have to go get stitches and get hospitalized, and now you have a recordable just because you didn't wait for that click. And my recommendation for them was just put a little LED light, so when it makes contact, it lights up, and now you know. It's easy. They weren't happy they had to change the assembly. Look in teach mode. You remember human interaction is huge. If you're on a collaborative system, that's going to be a big part of your risk assessment. A non-collaborative system, that's maintenance and teach mode. Humans should not be around a heavy industrial robot. And cybersecurity. I'm not going to really discuss that. That's for you to decide in your goal setting meeting. Is cybersecurity important to you? Do you work in Amazon robotics where somebody can gain access to the Amazon system just by plugging into that robot? Can you plug into the robot? Or is it an internet connection? Basically, how are the updates for the software instituted into that robot system? Is it just sent? Did someone plug in? Those are the things that it's up to you guys to decide. I am not a cybersecurity expert by any means. But that's kind of, what's the potential of that being an issue? So now the actual risk assessment, I've kind of talked about a lot of this, but when you look at each hazard, first thing you want to do is decide what's the severity of that hazard. Is being struck by a robot? That's probably a severe hazard. But something like a falling tool, it may not be a problem, that's a minor. And these are from the standards. There's kind of two different methods. This is the full risk assessment. That's basically just a piece of it. But you want to look, is it a catastrophic issue? And then it's for you and your company to decide, how do you define catastrophic? Death? Is a fatality catastrophic? That's usually yes for everybody. Some people might say, actually for us, anything above amputation, catastrophic. Some people might say, we don't want anything more than first aid. That's going to require a lot of risk reduction measures at the end, but that's for you to decide and define. Once you've decided, okay, you got your severity, next you want to look at what's the likelihood of that hazard occurring. Is someone exposed to it hourly or constantly as an operator? Is it a maintenance thing that gets on a PM monthly, so they got a monthly exposure? Is it something that somebody's just easy? It's very easy. Slip, trip, fall hazard is typically pretty likely, especially while loading. So you're looking at how likely is it, what's the frequency, and you can always fine tune your risk assessment. You don't need to just say, well, this is what the standard says, this is what it is. You can kind of go with it. Next is, how likely is it to avoid that hazard? Can that operator jump out of the way really easily, or are they stuck in a corner and now they're pinned? We have a problem. So can the operator, just by a little bit extra training, now knows everything, is avoiding that hazard, things like that. And then also, just before next one, think about the speed of your robot. Collaborative robots have requirements of speed limitations. So like if it's in collaborative mode, the max allowable speed is 250 millimeters per second. A typical operation is between 500 and 1,000. Industrial robots can move faster than that. It's just all in your programming. So. And then once you get all that, you can figure out what your risk level is. Like I said, from the qualitative side, you get high, medium, catastrophic, horrible, negligible, up to you. And then the CTI method, using a little bit of math, is we basically multiply what's the severity of that hazard, likelihood, avoidance, and then the frequency of exposure. And from there, those numbers that we put together, we get our number and we can tell you. And then what we do, which if you ever use a third party, hopefully they do this, in fact ask for it, is we provide risk reduction measures to say, hey, you have a high risk. here are the things you can do to lower those risks. And then we give you a little reassessment of if you followed this. These are what your new numbers would be. So it's up to you to decide, is this an acceptable risk? You might have a moderate risk, but you've done everything you can. It's just the potential is so low, but it's so severe that those numbers kind of pan out. And you say, well, we are saying struck by a robot, but we have guarding, training, notification lights, signage, speed limitations. So all the safeguards have been in place. We will accept this risk that it's not perfect, but it's low enough. And you can do that item by item. You don't need to say this number is good. So, and then if not, that it's not an acceptable risk, unacceptable, moderate, high, whatever, then you institute risk reduction measures, safeguarding, training, whatever it is, and then redo that assessment for that part. I'll just show you some examples of mine. I did a risk assessment during the construction phase of that cell, so things weren't put in yet. You can kind of see scanners on the ground, stuff like that. And then I gave them my unacceptable risk level with my numbers. I gave them risk reduction measures, some they were already in progress of, and then I gave them a reassessment and say, hey, if you do all this, this is what it is. And then they built it, shipped it to a facility, and I got to see it in operation, and I did a complete full risk assessment. Because a lot of the things, actually, that we had talked about, they went above and beyond and designed out of the system, which from the hierarchy of controls, that's preferred, instead of putting a sign up that says, caution, you can get hit by a robot. This is the table side. That was the full report part. This is kind of my appendix of just showing my math and stuff like that. And then I know this is really tough to see. Qualitatively, it's very similar, but instead of a 1 or a 10 or whatever, it's E3, S2, and then it comes out with that tree. So I just want to go over some risks. We talked about this once when you talk about this. What do you think is a risk of this robot in manual mode? Thank you. He can get hit by that robot. He will do it himself because he's operating it, but it's very possible. And the thing with collaborative robots that they have is they have speed, force, and power limiting sensors inside their joints. So they'll hit you, but then they'll shut off. And with robot systems like that, they are required to have a manual reset, not just automatically go, which is fine. So I've been hit by a collaborative robot really just out of curiosity. But you feel it, but it's not gonna knock you down too bad. But again, great. That's after the fact. It shuts down so it doesn't hit you again, but it hit you before. Those of you that have hit by, like I've been hit by a forklift. That doesn't mean that I was okay with it after the fact because he stopped doing it. But weld cells, welding robots. That's a big thing I see. What's the issue here? See if you can see it. When welding, you can see that arc. So how do you? Great. You can't access the robot. There's a light curtain, so if you reach your hand in, it's going to stop. But while it's welding, you can see that arc. So it's not actually the hazard inside the cell. It's actually from everyone standing outside of it. So the solution for that is just put flash screens around it, flash curtains around it. Some robot cells are fully enclosed. You load the part, it turns, spot weld, stuff like that. You can go above and beyond and completely enclose that cell. But one thing that this is why people pay me to nitpick, basically, is great. You can't open this door, it'll shut down. It's interlocked. You can't go through some of these windows as light curtains. It'll shut down. However, the parts can come in and out, which means there's a hole that someone can crawl into. And somebody's going to need to get something really quick. I'll just be in and out. I'll dodge that robot. Don't worry about it. I work out. I can do this. Well, that's great, but those robots move quick. And I've watched them many times, and I'm like, I did not know it was going to just spin. It kind of comes up with the most efficient route. So little things to look at. They may say, we spent, $65,000 to safeguard this cell. It's perfect. Yeah, I can crawl in there, and now there's no safeguarding. So, some other examples. So those were kind of my risk assessing tools. Safeguards, like I've mentioned, you really want to institute that in the design phase of your cell. It's a lot easier to say, let's build this robot system with these 3 e-stops, 2 light curtains, an area scanner, and sensors on the robot. Because then, when you buy all those things and put it all together, it's all in the system. If you do it after the fact, somebody's going to have to reprogram or add safety program layers on top of it. And then are those safety programs, are they good enough? If there's a short or fault masking, can it still run by accident? So these are the little things to look at. From the programming side, those integrators, keeping them involved with it and asking them a ton of questions is the way to go. Perimeter guarding we've talked about, which is the hard guarding. Protecting on the inside as well. Get that operator safe. Some things to think about with safeguarding is the devices themselves. Awareness devices, which is going to be your tower notification lights, your signage, and stuff like that. We talked about protecting the operator. Maintenance and repair, those guys are going to get closer than anyone to that system. And sometimes they can't fully lock out. I mean, lockout tagout's fantastic. We all know the benefits of lockout. If you're a VPP site, I don't need to tell you how important lockout is. But when that person needs to conduct maintenance on even the safety systems, how are they doing that? And I'll show you some examples. So some of the safeguarding methods, I talked about perimeter fencing. That's typically the go-to for a heavy industrial robot. Interlocking devices, presence sensing devices, audible and visible warnings, and then mechanical and limit switches. And I'll show you examples of all of these. So this is a Cayenne area scanner. It is fantastic. Basically, this one is mounted on the front of the cell. So as someone approaches, they have traced out the distances, and if someone gets within 4 feet, it slows the robot down. This is on a collaborative robot, so there's no fencing. So it slows the robot to 250 millimeters per second, which is the max collaborative allowable speed. If somebody gets right up to it and crosses onto that cell, it stops the robot and requires a manual reset. And there's another one on the other side that as someone loads corrugate for the packaging material, not only will it slow the robot, but it sends a message that the arm won't articulate in that direction. So you can program that how you want. And I looked at the program. It basically takes a picture of what's in front of it, and then you get on your computer and you just trace and color code slow, speed, fast, whatever it is. Fencing, interlocking devices, same with interlocked gates. You open it, shuts it down. Please don't use that as a lockout source. Putting a lock on it is great because then someone can't close it behind you and turn it on, but it's not going to lock out. Pressure mats are great. That's typically if you want to keep things in an area. So if you don't want to spend the time and money on a Cayenne area scanner, you can put a pressure mat. So if somebody walks on it, it shuts down the equipment. Or maybe you want the operator 10 feet away, so when they're on it, they can operate. But if they step off of it, it shuts down. And then things like dead man switches. This is the back of a pendant. This dead man switch, you can't operate in manual mode unless it's pushed. Some of them have 2. So if they let go while the robot's in manual mode, it's not going to move because they don't want it accidentally doing. Along with those are the complementary measures. Your lockout, tagout, your PPE, your training, e-stops, fantastic. Tower notification lights. Let the affected people in the area know, hey, it's in calibration, it's in collaborative, it's in operation, maintenance required, whatever you want. Training, signage, and then risk assessment as often as possible. For those of you that are branching into the collaborative, just a couple things to talk about that are different than an heavy industrial robot is collaborative robots do have speed, power, force limiting sensors. The last risk assessment I did with collaborative, the sensors. This was a Yaskawa Motoman HC10 robot. The sensors were so sensitive that it was operating full speed at 1,000 millimeters per second. Don't ask me why all the speeds are millimeters per second. But basically, by it turning, was so fast that it set off the force sensor and it shut itself down. So they were just showing me this because they wanted to know how fast can they operate. Well, not that fast. So they cut it to 50%. 500 is their operation speed. And then you get, someone walks in, collaborative speed, it slows down. And it's still, 250 milliliters per second, it's still moving, it's still doing its job. It's packaging typically. So those are the things to look at. You want your workplace clearly defined with collaborative robots. Like I said, they're made so you don't need perimeter fencing. So you need those definitions. Area scanners work great because you don't need the person to realize they're in a work zone. The robot will do it for them. And then, I think with them, we decided they're going to paint the floor different colors so people know that you're in a, red zone means, hey, you're within the reach of the robot. The safeguards include those two different methods I showed you. With collaborative, you do need a minimum clearance of 500 millimeters from any trapping point. So you don't want someone to accidentally get stuck. And that's tough with this because there's no fencing, but typically those arms are closer to the equipment or closer together to themselves. So you want to be aware of that. And then for collaborative, that switch from operation, full autonomous mode, to collaborative mode should be done without the operator having to push buttons. It kind of should be done automatically. So just a couple things to remember. Risk assessment. That's what I'm talking about. If you've been in safety, you're VPP, you know how to do a risk assessment. I'm sure you've done just several hundred JSAs in your life, audit your lockout procedures every year. You know how to do these things. But the big thing with the risk assessment is it's not a one and done thing. It should be done periodically. If you change a tool, you should redo your risk assessment because now you've changed the reach of that robot. If you get a different product, redo that risk assessment. You don't need the whole system of every robot to be redone all the time, but as changes go, if your operators are having issues and they tweak stuff, or maintenance has issues and they tweak stuff, redo that risk assessment. In fact, bring them in. Say, hey, you did this. Let's talk about how beneficial this is. Or is it not beneficial? You gotta redo those risk assessments. Ignorance is not bliss. OSHA shows up first, literally the OSHA inspector that trained us in RIA on it said the first thing we're going to ask is, where's your risk assessment? That's the first thing they're going to say. Oh, I didn't know I needed one. That's not going to mean you don't get to have one. I didn't know I needed to audit my lockout procedures every year. Well, they're going to cite you for it. So ignorance is not bliss. Keeping up with it, just being aware. You guys are here, so you're good. Using your A team. You had that team to help you with the assessment. Keep up with them. Make them a part of the process going forward. If you want to put a new robot system in, hey, we want this. People will say, hey, let's get a collaborative robot. I want that. The last facility they got a collaborative just, I think, because the person in charge wanted one. They're a little bit cheaper. That helps. Smaller, lighter. But then say, hey, what are your ideas on this? Here's the type of stuff we're going to have to look at. Get help if you need. You can call a third party. I'm going to always say a third party is fantastic. I'm a third party. But you can call RIA, ask OSHA questions. I call OSHA constantly with questions. I never tell them who I'm representing. That's not their business. But ask questions. Call your integrators. They should have a contract with you to help with troubleshooting. Again, collaborative robots still need protection and safeguarding. I cannot emphasize that enough. I would recommend offering annual robot training and safety awareness for both the operators as well as all affected employees. Like I've talked to some of you the last couple of days, but when you put a new robot in your facility, people want to see it. They're going to want to see it operate and stand there and just watch. So they need to know, hey, here's some of the hazards, by the way, if you get too close. Hey, I know it's collaborative, but please don't tap it. It will shut down. That's what it's designed for. Let them know that. And then, of course, in my mind, even with lockout tagout training, yeah, your authorized people have that. I train everybody on lockout tagout because if you see a sign and a lock, you should know, hey, please don't mess with that lock. And then use that risk assessment in the design process. that some of the examples I showed you, I did it with them in the construction phase of it, which was okay. It was a small enough cell. But if you do it in the design process, you want to do it again in the construction phase and then do it again in operation. Things change. You build systems in place on paper, and then someone puts it together, and they forgot to think about brackets, and now it's half an inch closer. Was that half an inch a big deal or not a big deal? I don't know. That's part of that risk assessment. So that's most of my presentation. Any questions about, oh, he's fantastic. I know. Any questions about robot systems, requirements, regulations, stuff like that? No? That good? Perfect. Well, thank you guys very much. Again, my name is Adam. I have my cards here. If you want to take them, feel free and email me with questions or stuff like that. Our next R1506 committee meeting is next week, so I'm sure there will be changes. I'll probably blog about it a bunch. But yeah, I'm here. I don't fly back till the afternoon, so let me know if you guys have any questions. Thank you very much. Thanks.